Hello everyone, Abagaba. My name is Chen Moyi, and I am a doctoral student of OPC. Today I want to talk about predict future traffic conditions by analyzing Google Maps. In recent years, an interdisciplinary integrated teaching model has taken the world by storm. It is STEM education, a teaching model that combines science, technology, engineering, and mathematics. STEM education emphasizes the integration of professional knowledge in the four major fields to fill the gap between different disciplines and the combination of courses and real-life situations to stimulate students' original curiosity and desire for knowledge, for novelty and knowledge. Many scholars in different fields believe that STEM has the potential to provide an important innovation mechanism for education, and it can be also used as an important element of future education reforms. What I want to talk about today is how to use STEM education to let senior high school students predict future traffic conditions by analyzing Google Maps. The process of this teaching activity is matched with the 6E learning theory proposed by Berry 2014 for STEM. Now let's go to the instructions. First of all is the teaching target. Google Traffic Map forecasting teaching involves abstract thinking and logical concepts. It is recommended that the teaching target is senior high school students. Second is the teaching hours. I suggest the teaching hours should be 9 lessons and 1,080 minutes. Thirdly, course introduction. The teaching materials of this course are mainly PPT and AR videos produced by teachers. The 6U teaching process is used to introduce the principle of prediction and how to make predictions. It is used with Google Map, a certain section of road, and Excel form to check and accept students' learning results true of. Now let's go to the class. Lesson 1, I will talk about factors affecting traffic congestion and how Google Map counts traffic conditions. Lesson 2, I will talk about butterfly effect, quantum entanglement, and chaos science. Lesson 3, I will talk about the prediction principles of weather forecasting and the similarities between genetic engineering technology and traffic prediction. Lesson 4, I will talk about the history and regularity of the forecast, the short-term and long-term nature of the forecast. Lesson 5, I will talk about quantitative research, the explanatory function of the structural model driven by theory, the predictive function of the unstructural model driven by the data. Lesson 6, establish a mathematical model and extract useful numbers for prediction. Lesson 7, use Excel table, statistics, and analysis. Lesson 8, practical operation. Lesson 9, evaluate. Use the actual traffic conditions of the road section as a reference to evaluate the students' prediction results. I also have some teaching suggestions. First of all, confirm that the student's prediction logic is correct. All the foundations of Google Map forecasting are based on an in-depth understanding of forecasting principles. To be able to complete the problem, the most important thing is the logic of Excel table, statistics, and analysis. That is, whether the theoretical knowledge is correct. If you can guide students to have correct and smooth logical concepts, most of the problems can be solved by the student's own ability. Therefore, I believe that logical is the most important part of this teaching activity. Second, each topic should be differentiated in difficulty. The differentiated topic design not only allows teachers to truly control the learning conditions of different students, but also allows each student to have a task during the teaching time. Teachers only need to set a basic passing standard, which is the entry question, and the rest implement differentiated teaching. Thirdly, students should use guiding thinking when encountering situations. When students ask questions, most hope that the teacher can give a positive answer. But in the teaching activities of traffic forecasting, unless it is basic knowledge, it is not suitable to give students the correct answer directly, because it may stifle students' creative thinking and reduce students' inquiry problem opportunity. When students ask questions, the teacher should quickly grasp where the student's problem is, and then use a method of guidance to let the student make the right decision. The author's usual method is to ask students to explain their prediction methods. If the students' ideas are not clear, they will consciously make mistakes in the explanation process. If the students do not find out, they will be guided from a logical perspective so that the students have the ability to self-examine. Finally, teachers should appropriately adjust topics according to students' learning conditions. In the teaching process, it is inevitable that students generally think that the question is too simple or too difficult. Teachers should adjust the level appropriately at this time to correct the difficulty to the general level of the student, so that the student can pass smoothly and increase the sense of accomplishment and confidence. Will be more motivated, not bored or frustrated. The foundation of the 6E teaching model is STEM-oriented, so each STEM subject can propose practical applications in the 6E teaching model. As shown in PPT below, I sorted out the correlations among STEM subjects, prediction-related knowledge, and 6E teaching mode, and clarified the relationship between them. Now let's look at the scientific principles. Teaching content. Factors affecting traffic congestion. Shorter and long-term predictions. Butterfly effect. Quantum entanglement. Chaos science. History and regularity of predictions. Prediction principles of weather forecasts. Learning stage. Engage, explore, explain, evaluate. Learning tools, PPT and AR. Next is technology application. Teaching content. How does Google count traffic conditions? Use Excel table statistics and analysis. Learning stage. Engage, explore, explain, extend or elaborate, enrich. Learning tools, Google Map and Excel. Next, engineering program. Teaching content. Similarities between genetic engineering technology and traffic prediction. Learning stage, engage and explain. Learning tools, AR. Last, mathematical concepts. Learning content. Quantitative research. Establishment of mathematical models. Extraction of useful numbers for prediction. Explanation function of structural model driven by history. Prediction function of unstructured model driven by data. Learning stage: engage, explore, explain, extend or elaborate, enrich, and evaluate. Learning tools: PPT and Excel. The importance of STEM interdisciplinary integrated education is increasingly emerging. The reason is that the performance of integrated theory and practical ability displayed by students when facing problems is one of the important core concepts of STEM, the main axis of life science and technology, and an indispensable high-level ability in the 21st century. I hope this video can promote STEM education. Thank you.